We're going to look at here the 5 major types of chemical reactions. They're not the only types or categories, but they're the major ones that we'll look at. And they're called synthesis, decomposition, single displacement, double displacement, and combustion. Displacement and replacement mean the same thing, so you can use either of those words. So first up here, we're going to look at synthesis. And when we see an example of this, here we see hydrogen and chlorine gas reacting to form hydrogen chloride or hydrochloric acid, hydrochloride gas. And we've got them coming together to form one compound. Now, just because this is a balanced equation, and yes, there's 2 molecules of the hydrogen chloride being produced, we are only making one product, one substance, so that's why it is a synthesis reaction. Decomposition is the opposite of that, when you have one substance breaking apart. Here we'll see calcium carbonate breaking down into calcium oxide and carbon dioxide. And it can break into more than 2 things, just depending on how complex it is to start. Single displacement or replacement, here we'll see iron will come in and kick copper out. And so we have like an element switch. And that's most common amongst the metals. Here we see the double displacement, and this is like a double switcheroo. Silver's with nitrate, potassium's with chlorine. Well, they're going to switch. Silver is now going to go with chlorine, and potassium is going to go with nitrate. And so that is what we call a double displacement or double replacement. And lastly, we have combustion, releasing a lot of energy. Here we'll see a hydrocarbon reacting with oxygen, because you must have oxygen in order to combust. And when this happens, we're going to see the formation of carbon dioxide and water, which is always going to be the products of a hydrocarbon combustion, a process that we call complete combustion that we'll see here in a second. So here are some examples in my notes on the types of reactions. So synthesis, you see, it also can be called a combination reaction, but it's when 2 or more substances react to form a single product. So here we see sodium and chlorine reacting to form sodium chloride, one single product, one substance after the arrow. And here's a little picture description of the reaction, or a little cartoon thing about dancing, if those help you or not. But anytime there's just one product, one thing after the arrow, it is a synthesis reaction. Decomposition is the reverse of that. So when a single reactant breaks down, so here we see potassium perchlorate, one single reactant, one substance before the arrow, and that is breaking down into potassium chlorate and oxygen. And again, it can break into more things depending on how complex the starting substance is, but you always only have one starting reactant. Single replacement on both sides of the arrow, the reactants and product side, we're going to have an element and a compound. So cadmium's an element, phosphoric acid is a compound. Cadmium phosphate is a compound, hydrogen is an element. And so we will see that one element will go into the compound and kick a different element out. So always an element and a compound on both sides of the equation. Whereas a double replacement or double displacement, you're going to have 2 compounds on both sides. And it's like a compound do-si-do. You're going to change partners, and you can hear it. Potassium carbonate and aluminum bromide. Switch. Potassium bromide, aluminum carbonate. So you can see that potassium was with carbonate, aluminum was with bromide, and then they switch. Potassium bromide, aluminum carbonate. Combustion, as I said, 2 types, complete and incomplete. Both involve a hydrocarbon, which is something made of hydrogen and carbon, and we must have oxygen. There was a riddle we did a little while ago. What happens if you're standing in a room filled with methane gas and you strike a match? Nothing, because there's no oxygen in there to support combustion. If there's enough oxygen around, we'll get complete combustion, and we'll see the formation of carbon dioxide along with the water. If there's not enough oxygen around, we'll see the formation of carbon monoxide, and water. And this rings a bell to some of you perhaps. This is why you should have a carbon monoxide detector in your house. Your furnace uses combustion to heat your home. Natural gas comes in, a combustion reaction happens, and warm air is circulated throughout your house. Well, if your furnace filter gets clogged, or if you don't allow enough air to get into your furnace, then you start producing carbon monoxide, and that gets pumped into your house. And why that's bad: carbon monoxide attaches itself to this lovely molecule called hemoglobin. Hemoglobin is what carries oxygen around in your bloodstream. And so if the carbon monoxide's attached, oxygen can't be, and you basically suffocate. You don't supply oxygen throughout your body, and if you're asleep when this is happening, you don't wake up. So make sure your carbon monoxide detector is good to go. Make sure your filters are clean and the airflow is good to your furnace, so that you'll have complete combustion forming the carbon dioxide instead of incomplete forming the carbon monoxide. So those are the types of reactions. Hope that helps you.